Okay, so today we'll do the word count example in the streaming itself. We'll try to see how you can use the existing capability of Hadoop streaming to push a specific script and run it in a map reduce manner. And this time we'll be writing the script using Python. Typically your map reduce is written to support Java things, and if you write it in Java you can directly submit it to the map reduce framework. But for streaming, that is the capability which Hadoop gives, that even if you have other languages known like Ruby or C++ or C Sharp as well as Python and Perl, you can use them to write your map reduce jobs and run it using the framework. So let's take a look at the input data that we have. So this is something which we already have in the, so this is a running Hadoop cluster that we have. The processes are already up and running. We'll just take a look at our input data that we have. So this data pg10.txt file is available. It's a text copy of the Bible book which is available at Project Gutenberg, and this is what we have used in our previous exercises. This you can download freely from internet. Let's take a look at the map and the reduce program written in Python. So this is a simple map program written in Python to count the words that are there in a specific file that comes in line by line. So that is where you're seeing thing here, that if you see here, you're using simply the executable specifying execution path for Python, and then for each line in std in, you are first stripping that line for any white space that you don't want to count, configuring the individual words which are coming in that particular line in the words array, and then for each of the word in a word array we're trying to simply print in a tab delimited manner. You can see I have hard coded the number as 1. This is exactly the same thing which we did, if you remember, in a Java based map reduce part. That's something when we practiced on similar lines we wrote, but that was at a Java level when we were setting the individual count using string buffer and all. Different languages gives you different capabilities to read the data and parse it up. Important thing to know as per the capability of streaming is that in streaming, your streaming API will act as an input for your map processes, as well as the streaming thing will act as an output for your reduce, which in turn will write it into your HDFS. So it's not the Java one which will write or which will create the input or push the input into a map process. It is the streaming process which will do the same. So the map and the reduce processes still remains the same. It is just that how the inputs are pushed into them as well as the outputs are taken, which gets changed into the streaming thing when you configure that. So just quit. This is a simple Python script for that particular thing which you write. In order to test that script, we have a file created here which has a single one line. Right now we will be just touching it with the online thing just to save. So this is Hadoop training for big data training. This is one sample line that is available in that file. If we give that file as a feed to our sample map program, it's able to, you can see, parse that particular line and throw individual tuples for each of the words which are coming in. This is exactly what your map even written in Java will do. It is not doing any aggregation at this point. This is a core output of a map process on this one. Let's take a look at the reducer process. This is the process which will take these individual tuples which are coming in, the key value pairs, and then aggregate them. In between it will also do the sorting, which is a default for MapReduce framework. This is where it uses excuse me, some Python logic to basically read the line. These are just some initial variable initializations. Pretty much the same thing. Read from now stdin, put that line, and writing the job itself on a more lower sense itself, simply converting it into integer or string to count, as well as this is where it is incrementing it and all, and populating the individual values. And this will again, if you have the Python things or Perl things, you will write accordingly your logic on it. But once you write your reduce program, whose responsibility is to take those individual key value pairs and join them together. Let's see if this reduce program written in Python script works out well. You can see it will give a specific thing here because it's not coming in, the input is not coming in a key value pair. That's what it is expecting, is the tab separated thing. So we'll make it a more piped thing. And we are right now just doing a local check that this is working for a smaller data set. If it works for a smaller data set, it's a good chance that it will put in, add the sort API in between, because that is what your map framework will be also doing, and then push it onto your reducer framework or a reducer process. You can see that when you club it up, it gives pretty much the same thing which is expected. Training is put into 2, but all other, depending upon their references, has been put into 1. This is what was the intention for our process also to do. So this is now more at a standalone level. You have a mapper Python process, you have a reducer Python process. We tested it with a sample file and the data that it has. And let's try to use these scripts, push it into the framework using MapReduce and utilize it. Have an output folder. 3 folders are already there. We'll create a 4th folder just to be more distinct at this level. So let's submit this process and see from its execution perspective how the execution is happening. In the contrib folder you have the Hadoop stream. You'll have to refer to that one to invoke the same, and then using the individual mapper and the reducer thing you will be calling that particular thing. Let's put FN input. This is where you'll have to, since you are submitting now as a job, you'll have to specify the input directory which is there in your distributed thing or HDFS part. Mention the output as create a 4th output directory. Till 3 it's already there, so should be good. And now you specify the mapper. Earlier we have specified the cat process as a mapper and the identity reducer as a reducer, which simply sorts the file based on the first character in the line. That was our first streaming job. This time both of these are custom created, so we'll also have to, not only we have to specify the process, but we'll also have to specify the location where they are available. So let me enlarge it, that will be helpful. I think this is still better, enlarging this. So we'll put here /home Oracle streaming map2.python, and using the file attribute you'll have to specify that this is the place where it is putting in, again map 2. So please remember that whenever you have a custom script you have to do things first using the hyphen file, or it doesn't, the sequence doesn't matter, all of these are taken in an array and then submitted to the job. To specify where is your map file using the file attribute, and then you have to tell that that is also the mapper for you, because you can use the hyphen file attribute to push other things like your distributed cache file and all. In this case this is the file which we are using as our map job, so you will use the same thing needs to be done for your reducer. Let's try to kickstart and run this process. So you can see that the output is put in output folder 4. Let's go ahead and analyze the output. You can see it's the same result as per the expectation. Shows the individual words and their counts which are available in this program, and you can see that if you write streaming program smartly, the effort can be very less compared to a actual map reduce program in Java. So scripting has its own advantages, just that what is the type of business problem that you are trying to solve, but this is where your Hadoop streaming helps you out. If you check it from a process perspective, you will be seeing that it should be available. The job tracker, this is the process that got completed. If we run it up, these are the statistics which it is excuse me, showing for the low level details that it has here. And visually also through the name node file system, you can go and check the output that you have here. That's something which is always available to go and take a look around and all. So this completes our exercise. So this completes our exercise for Hadoop streaming, both custom and the default one. We'll now switch to the next topic. Thanks for the session.